Welcome to our Part 2 lesson trying to connect proportional and non-proportional tables and equations. Many of you do not have access to papers at home, so what I'd like you to do in a few moments is I'd like you to pause this video and take notes on the two things that I've written down, just to make sure you have them in your notes. This is also something I'd like you to write down that we're going to go over right now. You're going to notice that it says proportional equation, and we talked about that in the last couple lessons. In fact, Mrs. Nord talked about it a lot last week. This is kx equals y, and that is only for proportional relationships, so that we're going to call this our proportional equation. Our equation that we talked about yesterday for a non-proportional relationship or table is this equation, and they look quite similar. If I just didn't have this pesky b in the way, they would look very similar, except for one has a k and one has a y. But that's what makes this proportional equation different. And because we do have a non-proportional relationship, that means that I have to add or subtract something. So I have a constant here. So let's continue. In our previous lesson, we discussed how to decide whether a table is proportional or non-proportional by using the y values divided by the x values. If all of the y divided by x ratios are equivalent, then the table demonstrates a proportional relationship. The value of that ratio is called the k value, and it's also called the constant of proportionality. If all of the xy ratios are not equivalent, the table demonstrates a non-proportional relationship. In this case, there is no k value. So would you please pause right now and write that information in your notes? So let's continue. However, for a non-proportional table, we'll discover that we could use the change in y over the change in x to find the m value for our non-proportional equation. Today we're going to learn how to find the b value in a non-proportional equation as well. But first, let's investigate the relationship between the equation and the table. In this proportional table, we're going to take the y values and divide them by the x values. That's how we can establish that it's proportional, and we can also find out what the k value is. So we're going to take the first y value, which is 12, and divide it by its matching x value, which is 4. And I'm going to do that with just one other y value with its matching x value, and we can see that when we divide, we get 3. So this is the k value. The k value is 3. Now in a proportional table, that immediately gives us a k value. We could also, if we wanted to, go ahead and find the change in y over the change in x. If I looked at every time I go from one y value to the next, I would see that this is moving up by 6. And if I looked at what happened every time I went from one x value to the next, I could see that this is moving up by 2. So this would be 6 over 2. And if we divide that, we also get 3, which we've already established. So we don't have to do this if we know it's a proportional table. We've already established the k value. So our equation, the main equation that we're looking at for a proportional equation, is kx equals y. And we've now established that our k value is 3. So this is what we know. And here's the awesome thing that happens with this equation and the relationship to the table is I can now use that k value and all of my x values, and I should get back the matching y value. For instance, if I put in this 4 and I multiply that 4, then I should get back my matching y value, which is 12. And sure enough, if I look at that, 3 times 4 is indeed 12. And that's going to happen every time I take my next x value, which is 6, multiplied by my k value, 3 times 6, and I do get back 18. So 4 and 12 match up in my equation. 6 and 18 match up. And this will continue to happen for every value. Knowing that allows us, if for instance somebody said, well, what would happen if you had 20 for an x value? Well, then I could take 3 times 20 and I'd be able to say what our matching y value is, which is 60. So that's the beauty of the equation. So now let's see what we can do with our non-proportional equation. In this case, if you recall, trying to find the y over x is not going to yield a k value, or for that matter, an m value. If I took 14 divided by 4, I would get 3.5. If I took the next y value divided by its x value, I get 3.6 repeating. And already we can see I don't have a constant. I don't have a k value. So that's when we decided we needed to resort to some other way to establish this number, a number that might have helped generate this table. So we did that by talking about the change in all of my y values, which in this case, every time I go from one y value to the next, it's changing, going up by 6, over the change in all of my x values. And every time I go from one x value to the next, it is going up by 2. So this would be my m value. My m value is 3. And so now let's see how that relates to the equation. If you remember, our non-proportional equation looks like this. Mx plus some mystery number b equals y. And we now know that our m value is 3. So we have this much of the equation. And here's what's awesome. Because we have a whole table of x and y values, we're going to be able to substitute in x and y, and that's going to help us figure out what the b is. So let's start with our first x and y value. I'm going to take our m value, 3. I'm going to multiply it by our first x value, which is 4. We don't know this b yet, but we do know that our y value that matches with the x value is 14. So if I do a little bit more math, 3 times 4 is 12, plus our mystery b, and that equals 14. Now we have a couple ways to figure out what that b is. First of all, we can use our logic. We can say, 12 plus what number would give me 14? If you said that number is 2, you're correct. If you didn't see that, we can use our solving skills and get rid of the 12 on this side, which is going to leave b, and I have to do whatever I do on one side, I have to do on the other. I now have b equals 2. So now we've clarified that yes, b equals 2. So we now think that our equation, and I'm going to replace that b up at the top, we think the equation for this table might be 3 times x plus 2 equals y. Once we've established that equation, we want to go back and make sure it works for all of our table values. So here's our equation, and what we're going to do is we're going to now go on to the next set of x, y values. Right there, we're going to use our 6 and we're going to use our 20. So we're going to take our m value, we're going to take our m value of 3 and multiply it by our x value in the table of 6. We're going to add our b value, plus 2 in this case, and we're going to substitute our y value with 20. Those are the two things that go together on our table. So let's see if this is true. 3 times 6 is 18, plus 2, and does that equal 20? Well, it does. So we now know that this equation worked, but we want to make sure that we use it for another set of values. just to be sure. So we can choose either 8 and 26, or we could even choose 10 and 32 if you prefer. So let's try this 10 and 32. Let's use these. So we're going to go back to our equation, and we're going to say, all right, 3 times, this time we're going to put in 10 for our x. Our equation, we figured out we had to add 2, that's the b value, and if this all works out well, it's going to give us back our y value of 32. So 3 times 10 is 30, plus 2 more, then yes, this equation works out. So our equation of 3x plus 2 equals y is the equation that goes with this table. So now let's practice a few more of these. Let's turn to the next page, because I know when we learn something new, we need to see it several times. All right, so we're going to turn our focus on defining the equation, the m value and the b value, from a non-proportional table. And you're going to notice that I've already put the outline of our non-proportional equation. So let's start first. If you recall, we need to start by figuring out what the m value is. And we do that by finding the change in our y's over the change in our x's. So I'm going to start with the y's, and as I look at this going from 5 to 7, 7 to 9, 9 to 11, that is all going up by 2. So I'm going to write a positive 2. If I look at my change in my x values going from 1 to 2, 2 to 3, and 3 to 4, that's a change in 1, positive 1. And so if I take 2 divided by 1, I get 2, and so our m value equals 2. So now we want to move forward and find the b value, because we have now found our x value. So let's see what we can do. We're going to take our m value of 2 and put it where the m is, and then I have an x and I have a y in the table, and these are pretty nice numbers to work with. So I'm going to replace my x with this number 1 from my table right here, first x value. Still don't know my b, that's what we're looking for, but I do know a y. The matching y value is 5, so I'm going to place the y with 5. So 2 times 1 would be 2, plus b equals 5. And we can use our logic and say 2 plus what number would give me 5? And if you said 3, that was correct. If you're not sure about it, what you can do is you can, having technical difficulties right here. You can use your solving skills to prove that answer, that b, is 3. So we now think that our m is 2, our b is 3, so let's replace b and m in this equation and check it. So I think the equation might be 2 times our x values plus 3, and that should give us back our y values. So let's go on to the next ordered pair. In this case, it's 2 and 7. So we're going to use the x as 2, and we're going to use the y as 7. So we have our 2, which is the m value, and then our 2, which is our x value, both happen to be 2. Then we're going to add 3 to it, and it should give us back 7 if our equation is correct. So 2 times 2 is 4, plus 3 equals 7. That works. Now, if I had a little bit more time, I would go ahead and check one more x and y pair, but for time's sake, we're going to go on to the next equation. So now let's look at another table and see what happens. Let's start this all again. We're trying to establish our m value, and we do that by trying to find the change in y over change in x. So as I go down this y column, it's going up by 1 each time I go from one y to the next. And as I go down this x column from one x to the next, it's changing by 1 also. So 1 divided by 1 would be 1. So our m value is 1. How are we going to use that? Well, we're going to replace that m right now with 1. Since we're trying to find the b value, we need b by itself. We need all the other variables to become numbers. And sure enough, right here we have an x and we have a y. So I'm going to use this x value of 3, trying to figure out what the b is. And I'm going to use this y value. 3 and 1 go together, so I'm going to use that. So I have 3 plus b equals 1. Oh, this is confusing. 3 plus what number would equal 1? Well, I can't think of 3 plus a number, but I can think of 3 minus a number. So I could, oh, guess what? We can use a negative here, because subtracting a positive would be like adding a negative. So if I added -2, I would get back 1. So I think my b value, we think b equals -2. So let's see if we can do that. Let's try our equation. Our equation, the m, is 1. I'm supposed to take the x values, 1 times the x values. Instead of, I can either add this -2 to get back the y's, or because adding a negative is the same thing as subtracting, I could subtract 2. So whichever form of the equation you prefer is what we can use. And I just want to remind you that we can always write this mx plus b as minus b instead. In this case, maybe that might be a little bit easier. So we'll try this. We can pick any ordered pair we want from the table. I think I'm going to look down at the bottom right now and use 6 and 4. So I'm going to take 1 times 6. Right, there's my first, the x value that I've chosen to use. I'm going to subtract 2, and it should give me back 4. So 1 times 6 is 6, minus 2 will give me 4. And if you use the equation in the other direction, if you took 6 plus -2, if you chose to use it this way, that would certainly give us back 4 as well. So our equation, 1x minus 2 equals y, worked. Our 1x plus -2 equals y. And in this case, we could even write it as x minus 2 equals y, because 1 times x would be the same thing as x. So I'd like you to try the next one on your own. In lieu of having another practice set, I'd like you to try this on your own and then unpause the video to look for the answer. So first, we found the m value by finding the change in x over the change in y over the change in x, which was 5. We inserted that in the equation as our m value, 5x plus b equals y, and we're able to fill in our first x and our first y to find out that b equals 1. Next, we replaced the m, we replaced the b in the formula here, and then we also checked another ordered pair, in this case 3 and 16. And so this was true. 15 plus 1 equals 16. I hope you found those answers. Our final equation is 5x plus 1 equals y. Tomorrow, we're on to our next topic, which is percents, and we will come back and revisit this. We actually got the hardest part out of the way. Tables and equations are the hardest part about, I think, about proportional, non-proportional. Next time we visit this, we'll go on with the graphs. Thank you for your time.